Chapter 8, Lesson 1, Letter Problems. Turn to page 590. We are doing letters A through D. First of all, letter A asks you to solve a volume of a cylinder problem. So we have volume equals the base, area of the base, times the height. The area of the base, because it's circular, because it's a cylinder, it's a circular base, so it's pi r squared for the area, and then we multiply it by the height. In other words, the distance between those two bases. And if we look at the diagram, we've got pi times a radius of 3, so it's pi r squared is pi 3 squared, times the height is 1.8. Plug it into the calculator and it's quite easy. We get 50.9, and again we're talking cubic inches because we are talking 3 dimensions. Volume is a 3-dimensional measurement. Letter B, we have another problem doing something similar. So we have the same formula for the volume of a cylinder, and it's pi r squared times the height. However, they give us a diameter, and we have to notice that that's a diameter so that we can reduce it by 1/2, cut it in half, divide by 2, however you want to look at it. So the radius is 6, so our formula becomes pi times 6 squared times the height of 5, and we get 565.5 millimeters cubed. Problem letter C. We have in this problem a height of 4, nice and easy. It's a word problem. It gives us the diameter, however, so immediately we should take the diameter and turn it into a radius by dividing by 2. 1.5 divided by 2 is 0.75, or 1.5 divided by 2 is 3/4 in fractions. And then I just put in here a note to myself to remember that they talked about the fact that it weighs aluminum cans weigh 37 ounces per square foot. So we are going to multiply by that 37 when it gets to that point. But the first thing we have to do is figure out the volume. Once again, volume is the area of the base times the height. In this case, again, it's a cylinder, so we have a pi r squared. The radius is 0.75, so pi times 0.75 squared times 4. This part of the problem right here will give us the volume, but we're going to go ahead right away and multiply it by the 37 ounces per square foot. And again, we put that in a calculator, round it to the nearest tenth, which we're going to do on every one of these problems, and we get 261.5 ounces of aluminum. We have a rectangle and we have a half cylinder. This is a composite solid. We have a rectangle, and then if we could kind of hold this like this, we have this sitting on top of it. So we're going to figure out the volume of the rectangle, and we're going to figure out the volume of the cylinder and cut it in half in order to get the volume of the semi-circular cylinder. Okay, so the volume of the rectangle plus the volume of 1/2 of the cylinder. So it's 1/2 of the base times the height. In this case, it's the base times the height. Okay, so there's our formula. Now with some numbers, D continued. The volume equals 30 times 25 times 50. That is the 3 dimensions of the rectangular base of that. And then we're going to add to that 1/2 of the volume of this base, which is a circle, so it's pi r squared times the height. Now notice I've got some lines through here. I'm going to show that there's an easier way to do this. You could do this several different ways. You could put this into your calculator. Since we have a diameter of 25, we have a radius of 12.5. We could put 1 divided by 2 times all of this, or you could put 0.5 times pi times 12.5 squared times 50. But to me, it's easier once I have this written down to say that 1/2 of 50 is 25, and I make my formula a whole lot easier. Whenever you have an even number and you're multiplying by 1/2, I would just cut that one even number in here in half and make things easier to put in the calculator. Put in the calculator pi times 12.5 squared times 25, and we get these two volumes here. This here is 37,500 for the rectangle, and then for the semi-cylinder it's 12,271.8. Add the two together and we get 49,771.8. Okay, this is the explanation for guided practice, page 592, lesson 1, chapter 8. The first problem is a volume problem. You are given the radius and you are also given the height of the cylinder. So because it is a cylinder, its volume equals area of the base times the height. So that's pi r squared times the height. The radius is 1.5 and the height is 8. So pi times 1.5 squared times 8. Really simple problem. Put it in the calculator, 56.5. And again, we're talking cubic centimeters in this case. So that is the solution to problem 1, guided practice. Problem number 2. Again, we have a cylindrical object. We're finding volume, but they give us diameter. In this case, we use the same formula, pi r squared times h. Because we have a diameter, we cut it in half. We end up with a radius, plug it into our formula. We have pi times 4 squared times 8. In the calculator, we have 402.1 cubic inches. 402.1 cubic inches. Problem number 3 in guided practice. In this case, we have a complex shape that doesn't look like this. I'll talk about that in a minute. But if you take a look at the diagram in your book, much easier to look there than have me draw it here, we're going to find the volume of that top square prism, and we're going to find the volume of the bottom, also a square prism, and we're going to find the volume of the cylinder in between. But there's a little trick you can do here. You can take this top and the bottom, they're the same size, so you can slap one onto the other, and you have a 20 by 8, and the top one is 5, the bottom one is 5, so you have a really nice one singular object here. This is just length times width times height on a rectangular prism. In this case, it's going to be 20 times 10 times 8. Once we put them together, the two 5s become the 10. So we have 20 times 10 times 8. We can do that in our head. 20 times 10 is 200 times 8 is 1,600. So we have 1,600 for that volume. Then we're going to move to this one, the volume of the cylinder. If you take a look at the diagram in your book, they give you a diameter of 8. So we're going to turn it into a radius of 4, and we have a height of 15, so it's pi times 4 squared times 15, and that results in 753.98 in the calculator. We round it up because it ends up as 754, and your grand total for your answer is 2,354, and they're meters, so we cubed them, meters cubed. Problem number 4. In this case, we're given the radius of a cylinder, the height of the cylinder, and then they're telling you that 1 cubic centimeter is 35 grams. So we're going to use this to figure out the volume in cubic centimeters. Once we have that, we're going to multiply it by the 3.5 in order to figure out how much all of this would weigh. Get the volume first. So that's volume is the base times the height, area of the base, remember. Pi r squared, since the radius is 4, it's pi 4 squared times the height of 12. And then we're going to multiply right away times the 3.5 grams per cubic centimeter. And put it all in the calculator, very easy. 2,111.2 grams for your final answer. And then lastly, problem number 5. It says, how is the formula for the volume of a cylinder similar to the formula for the volume of a rectangular prism? Hopefully this was very easy for you given the introductory lesson where I repeatedly talked about area of the base times the height. Area of the base times the height. Area of the base times the height. We could even take this complex looking thing, figure out if they gave us the area of the base, we would just multiply it by the height and we would have the volume of this hexagonal prism. Again, we would figure out the area of the base, which is a triangle, multiplied by the height. So the answer, simple answer to problem number 5 is they are similar because in both cases you find the area of the base and multiply it by the height. That's how they are related.